Today it's Monday, June the 29th, 2026, and what we have here is a three-phase AC controller, three dual SCR, A, B, and C, and we have it fed from 480 volts from our wall, and we are monitoring with a CT the current out of the AC, from the A line, and then we're monitoring our output with a differential between A and B, the 0 to 480 volts, and we also have here our multimeter. Right now the board is inhibited, so we're not reading any output, and we also have on channel 1 TP5 or phase reference. It's a 50% duty cycle, 60 hertz signal, and we have our delay angle on channel 2. Channel 2 or delay angle right now it's maximum because our command is minimum, so that basically the SCRs will generate minimum output. We have two waveforms on top of each other. Green on channel 4, it's our current out of our CT, and then channel 3, it's our AC output voltage from the differential probe. So let's go ahead and enable the board. So we see that no changes on the delay angle, no changes on the reference, and we have a little bit of an output, and according to the setting on the span and bias of this particular board, we have 9 volts of output. We could open up the delay angle range to have it go to 0, but that's not important in this particular case. So what we're going to do, we're going to start increasing sig high. And we notice how all the SCRs are starting to commute until when you have the maximum delay angle. And again, we should really extend the delay angle range of our board so that we will have close to a perfect sinusoidal wave without the commutation notches. And we have 476 volts on the output. This is again looking at the A and B phases on the output. So, again, if we were to open this up, if this were to be a true AC controller, we would just widen still the delay angle range, but we can see that. So we can come back, and we notice here that the delay angle has actually been reduced. Now we have the minimum delay angle for maximum sig high. You want to go ahead and bring it back, and we'll notice how this leading edge here coincides with that commutation notch. We'll see how it follows. Go ahead and go ahead and start coming down. See how that stop right. Go ahead. Keep on going. There, right there. Right there is good. You notice how that on the vertical line coincides with that. All right, and that's part of the commutation notch. And we're only this right here. It's the A reference. If we had the B, we will have it here, and if we had the C, we will have that on the different commutation notches for all the 6 SCRs. So go ahead and start bringing it down. All right, thank you. So we're back to now 10 volts, and again, you can still see. Now I'm going to bring in now the current, and by the way, there's only 20 milliamps per division. That's the way we set it up. So now here we have those two dual spikes that we're questioning. So there we have it, and again, keep in mind that this is right here, this is 180 degrees, and right here it's 360 degrees, and there we have the spikes of current of all 6 of each one of the SCRs before they start to commute. Let's go ahead and start increasing current. So hold on, it stopped right there, so we can see it now there. There you got the 6 SCRs, and go ahead and keep on going. And now when we have that, then now you have the full sinusoidal wave. Again, these are at different amplitudes, however we can see a phase shift there. And on this particular case, it's has to do with our the setup of our board, because we should not introduce a phase load, and this will change as a result of the load. If you have a load, or if the load is conductive, then the voltage will lead. If it's capacitive, then the current will lead. But basically that's what it is. You have your full sinusoidal current waveform, but as you start decreasing sig high, you can see when that, go ahead, that now comes down to 0. So let's go ahead and look at the voltage again. Go ahead. Reference never changes, delay angle starts decreasing, the waveform starting to to resemble close to a sinusoidal wave. Okay, go ahead, give 1 second. There's the current. Alright, go ahead, now looking at the current, and there we get the contribution of our SCRs until we get that, and we go to, again, if we were to widen our delay angle, we will get that to 0. Go ahead, bring it back to 0. All the way to 0, please. And again, if we were to widen that, we will get rid of that, the 10 volts and the little current. This is 20 milliamps. So here we have close to 3 or 4 milliamps based on our lamp. So this is the end of this video.